Okay, we're going to continue graphing systems of inequalities. On this handout and this page of notes, we're going to go ahead and graph standard form inequalities, and it shouldn't be any difficult. It's the same thing as equations. We just have to remember when the golden rule occurs. So let's begin by reviewing. If you have a less than or a greater than symbol, the symbols that don't have the equal sign at the bottom, what kind of line do we use? Well, we use a dashed. If you have the ones with the equal sign at the bottom, obviously it's going to be the opposite. We're going to use the solid line. Anytime you have a less than or equal to, we're going to shade below. And remember, you must always stand on the y-intercept and then make an arrow down. And if you have the greater than or equal to, we will shade above. So let's begin with the first example. We're going to go ahead and take this system of inequalities and we'll graph it on the grid below. Okay, but first, in order to graph it, we got to be able to change it to slope-intercept form. So let's take the first one. 2x plus y is less than or equal to -1. And let's move the term with the x. So I'll move it over. This is going to become y less than or equal to -1 minus 2x. And it's already in slope-intercept. So here, my y-intercept is -1, and my slope is -2, or I can write it as -2/1, so I know what my rise and run are. So I'm going to use that information. Remember, I said that I want you to be graphing one inequality at a time, okay? So we're going to plot a point at -1. That was our y-intercept. And -2 means we're going to go down 2, but the 1 is positive, so we're going to go to the right. Down 2, right 1. We can also go up 2 and 1 left. If you choose to give that little negative to the bottom one instead, the 2 would become positive, so you go up. The 1 would become negative, so you go left. And our inequality had the less than and equal to sign. So because of the equal to sign, we're going to go ahead and use a solid line. And less than means we shade below. So I come down here, make an arrow pointing down. That is where I'm going to shade. There it is. So now I'm going to go back, get the second inequality from my system, right here. X minus y is greater than or equal to -2. And I'm going to solve it for y. So again, get the term with the x and move it over. So I'm going to have -y greater than or equal to -2 minus x. And I'm going to divide by -1. Golden rule. So I have y. My sign flips. Negative and negative is positive. Negative and negative is positive. So my y-intercept here ends up being a 2, and my slope ends up being a 1, or simply 1/1. So let me use that information to graph. So dot at the 2, the y-intercept, and then go up 1, right 1, down and left. And I'm going to use a solid line as well because it was the one with the equal to sign, and it's the less than, so I'm going to be shading below. So solid line, go to your y-intercept, draw an arrow down. That's where we're going to shade. All right, so as you can see, there's an area that has the green and the yellow. So this part right here is where my solutions are going to be found. And I'm going to also make a note, and you should do this when you're working on your own questions, that if you've got 2 solid lines, guess what? The point of intersection will also be a solution because they're both solids, and we know that those points count, okay? So let's see, it says, is 2, 1 a solution? 2, 1. Nope. How about -4, 1? -4, 1. No. -1, -3. Yes, that's in the double shaded. And -2, -3 is also in the double shaded. Okay, so that's our first example. Let's go to our second one. So let me fold the paper so we don't get distracted with that one. Okay, so another system here. They're both in standard form, so I guess we're gonna have to change them to slope-intercept ourselves. So 4x minus 3y is less than negative 3. I'm gonna move this term over here. So I'm gonna have negative 3y is less than negative 3 minus 4x. And I'm gonna divide everybody by negative 3. So golden rule, y greater than negative and negative is just positive 1. Negative and negative is positive, but it's gonna stay. So there it is. So I know it's gonna be a dashed, and it's gonna be shaded up because I have my greater than symbol. Okay, so let me go down here to my grid. My y-intercept was the 1, and my slope was 4/3. 1, 2, 3, 4 up, 1, 2, 3 to the right. Or 1, 2, 3, 4 down, and 3 to the left. Dashed line, and shade it up. Okay. Let me go back, and let me change the other one. So 4x minus 3y is greater than 6. Notice that they almost look identical, except the signs are different and the last number is different, but the beginning part is the same. So let's move this term with the x. I'm going to end up with negative 3y is greater than 6 minus 4x. I'm going to divide by negative 3. Golden rule. So now this is going to be a less than. 6 divided by negative 3 is negative 2. And this is going to be positive again, but it's going to stay as a fraction because that's my slope. So y-intercept is a negative 2. So there it is. Go up 4, right 3. 1, 2, 3, 4, 1, 2, 3. Or I can go 1, 2, 3, 4, 1, 2, 3. It'll be like somewhere over here. It's also going to be dashed. But this time I'm going to shade below, under. So I'm going to go here, make it the little arrow. Now what do we notice? There's no overlapping. Okay, we know that a solution is going to be found in the double shaded, and there isn't any. So what are we going to write? We're going to write no solution. Negative 3, 1, negative 3, 1. I mean, it's never on the double shaded. There is no double shaded. So this system has no solution because they're parallel lines. They don't cross, but their shading doesn't cross. It doesn't overlap. So let's put right here, no solution. So kind of take note of when that occurred. When the beginning part is the same, last number's different, and the signs are switched. You see that, how they're switched at the beginning? Okay, so that's when that's gonna occur. Okay. 2 more examples. Let me fold my paper, here it is. Okay, so let's see if you can recognize what format the first equation is in. It's not in y equals mx plus b, it's not in slope-intercept, it's not in standard form because I don't have x together with the y. The third one that we learned was point slope, okay, point slope. And it's called point slope because that's exactly the information that you should be able to grab from it. So from this equation, I should be able to grab the slope and a point, which is the information you're going to use to graph. We're not going to graph it the way we do the others where we start at the y-intercept and then do the rise over run. No, we'll know our rise over run. Slope is always found right in front of the parenthesis. So we know our slope. You don't know your y-intercept all the time. You know another random point. So we're gonna have to get that point. So it's always x first, then y. So I'm gonna go to the x side. Remember the trick here. You always have to take the opposite. So if it says plus 2, here you're gonna put negative 2. Go to the y. If it says plus 2, you're also gonna put negative 2. And this is what you're gonna graph first. It sort of becomes like your y-intercept, your beginning point, but it's not a y-intercept. So I'm gonna go to the grid, and I'm going to plot the only point I know, negative 2, negative 2. There it is. And from there, I'll do my rise and run. So up 2, right 3. Or down 2, left 3. What kind of line am I going to use? Well, I'm going to use a dashed, and this is the less than, so I'm going to shade under. So here's where my y-intercept would be. Under would be down here. Okay. The second inequality, I only see x a number, so that is a box. So I'm going to go to the x-axis, look for the 1, and put a dot there. And box means you're going to draw it vertically, and it was the less than and equal to, so it's going to be a solid vertical line that is going to be shaded less to the left. So there it is. So let's check for solutions. There's an overlapping right here, so I know that this is where they're going to be found. 0, 0 is not in the double shaded. -2, -3, yes it is. 1, 1, no. And 4, -2 is not a solution either. Okay. Last example. This one right here. Notice now I gave you 2 point slope just for practice. Okay, so let's take the first one. Let's figure out the slope. That's easy to do because we just got to look right in front of the parenthesis. So it's -1/3. Let's grab the slope. Not the slope, sorry. There's the slope. Let's grab the point. So go to the x first. Take the opposite. So if it says -1, you're going to put 1. Take the opposite of the y, -4. And let's plot it. We're going to use this symbol. Symbol doesn't change here, okay? So we're going to go greater. So we're going to go up and dashed. Okay, so let's go ahead and graph it. Graph your point, 1, -4, and then do your slope. Down 1, right 3, or up 1, left 3. And it's going to be dashed. And we said greater. Okay, the next one. The slope is -3. And the point, if I go to the x and take the opposite, it's going to be -3. If I go to the y and take the opposite, it's going to be -3. So that's the point that I'm going to plot first. -3, -3. Right there. And I'm going to do my rise over run. So it's a -3, so that means down 3, right 1, but I have no room. So I'm going to go up 3, left 1. Up 3, left 1. And in this case, it's going to be a solid line shaded upward. Where is upward? Well, if I kind of picture this going all the way down, the y-intercept's going to be somewhere here. Upward would be all of this right here. So we've got a big range of solutions, okay? 0, 0, that is in the double shaded. -3, -5, that is not. 2, 5, definitely is. And -3, 2, that one is also. So we found 3 solutions there. Okay, so now you're going to practice in systems in standard form, and you're going to practice systems that are in point slope. Good luck. Use these notes.